Hey, welcome back to my lab. This video is about this unit here. This is a Rubidium based portable frequency standard, at least that's how it's marketed by this company called Efratom. It's made by Efratom, quite a popular, well-known manufacturer of this unit. This unit has an oven-based frequency standard, which is also built by this company called Efratom. So, any case, I bought this from a seller on eBay, and he assured me the unit is working or was working fine, and he shipped it to me. I plugged it in after I got it in the mail, and it doesn't even want to power up. I looked in the manual, I downloaded the manual, and I looked in it. It doesn't say anywhere in the manual that the power on comes up after a certain time or after the oven warms up. None of that stuff. So it's supposed to light up soon after you plug it in, and it doesn't. I left it powered on for whatever 30-40 minutes, and nothing happened. So I contacted the seller, and he said, "Hey, when I shipped it to you, it was working. We tested it, blah blah blah." And I said, "Well, it doesn't work." And then he also did a really bad job of packing this together, and it came in a clunky cardboard box, and it was all wobbly and whatever. So that was one problem. The second problem is this unit was completely marred with dirt, and it wasn't well taken care of. And my message to the seller was, well, even for courtesy, you should have cleaned the unit before you shipped it. Any case, long story short, the unit is not working, and I complained to eBay and asked them to step in and help resolve this. The seller was telling me that he wouldn't send me a return label, that I have to bear the cost for the return and then send it back to him. And I said, no way I'm going to do that. I already paid the shipping for him to send it to me. I'm not going to pay another, whatever, $50-$60 to send it back to him. So I asked eBay to step in, and they said, hey, we'll open a case. If the seller doesn't fix this, we're gonna refund you the whole money, and you don't have to ship this back to the seller. I said, okay, that's a fair enough deal. So the case closed this afternoon, so they supposedly will be refunding my full payment for this, including the shipping I paid for the seller to send it to me. And then I have this with me now. The unit is not working, and I need to figure out a way to maybe fix this. So that's the story. That's the genesis of this video, and I'm hoping I'm able to maybe look through the circuit diagrams and here the schematics, figure out what's wrong with it, and then see if I can fix it. And if I can fix it, that'll be great. I can use it in my lab. I had this Rubidium based 10 megahertz frequency standard. It works great. So this would be my number 2 frequency standard. The reason why I had purchased this to begin with is it has an option here. Let me see if I can zoom in a little. Okay, so this has a knob where you can select from a selection switch, where you can TTL a square wave for 1 megahertz, 5 or 10 megahertz. I'm not sure how accurate that would be, but in any case, this one has that option. And then this BNC is the output. But you can also have a 5 or a 10 megahertz sine wave, which is great. So I thought this was kind of a very versatile kind of a unit, and that's the reason why I bought it. And I know Efratom is a very well-known company, so I didn't have any concerns about that. But of course, the unit is not working. So my job, hopefully, if I can figure this out by reading through this manual and the schematics and such, I'm hoping to see what I can do to maybe fix this. I know for a fact that inside of the box there is a 24 volt power supply unit. I think it's somewhere here. Maybe that's gone bad. I don't know. The fact that it's not even powering up tells me that the power supply unit has gone bad. I checked the fuse in the back. There's a slot for the fuse in the back, and that seems to be fine. I tested it. It seems to be fine. So it's not the fuse. I already checked that. It's probably the power supply unit that's gone bad, I'm thinking. With that, let me get this started, and I want to get this opened up and see what's going on, and then I'll do some testing on the power supply. I'll do another test on the fuse one more time before I open this up, and do some discovery and go from there. So here's the rear side of the unit here. There's that heatsink providing or supporting the internal rubidium oven. This is the fuse box, and here's the model. Let me see if I can get a quick zoom in. So that's a PRFS-202. There's one concern though, I think, about the oven, not so much about it not powering up, but I think if you look in the date, year is 98, 10th week. So I wonder how stable this rubidium oven is in terms of how stable and how accurate is this rubidium oven going to be. I'm not sure, but because over time rubidium tends to lose its accuracy and stableness. But hey, well, let's get this powered up first, and then we'll get into checking its accuracy and stability. All right, so I'm going to open this fuse box and see if I can get it to, if I can do another quick test on that. Okay, so this is a slow blow fuse from the looks of this filament. It is a 250 volt 3 amp fuse. So that seems to be fine. I don't see any issues there with the fuse. All right, so that seems to be fine. Like I was. So I'll get this opened up and start looking into things, and we'll go from there. Okay, so there are 4 hex nut screw here, and that are holding these feet together. And I think once we open this top lid should hopefully slide out or maybe lift. So let me get that going here, and we'll try to crack this open. I'm just going to try the top section first and see if that's enough. Okay, all right, so let me move this around. Okay, that's sliding out. That's a good sign. Okay, so there's this ground clamp. All right, that frees up the top lid. I'm going to put that aside here. Okay, so this is the rubidium oven made by Efratom. That's the power supply unit. Obviously, somebody had been here before. And that's the, I think they call it the control board or something like that. In any case, so that's that. And let me see if I can get you another view of the oven. Okay, so that's the oven. These are all very well documented, by the way. So, and it is the same It is the same oven that's also in my other Rubidium frequency standard. It's exactly the same. The power supply, I think this is the 24 volts that goes into the oven. I'll have to look in the circuit diagram, which I will do. Although it looks like this cap is burnt. Looks like a tantalum. So I'll definitely have to check that one. I see something is, looks like something is burnt there. It looks like the trace is damaged somehow. Yeah, that looks like a trace problem. Here's another one. I think there are 4 of these, C1 through C4. From looking at the circuit diagram, I think there are 4 of these caps and they all look the same to me. First of all, I need to read up on the circuit schematics and then see if I can find out anything from the documentation. And then I'll need to check and test this unit, if it's working fine or what. And then we'll go from there. I hope the oven is not busted because of the bad PSU, or the board is not busted because of this cap getting burnt. So I wonder. So it looks like that needs to be replaced for sure. So I've ordered some parts from DigiKey. They should be here in a couple of days. But before I go into the documentation and studying this circuit a little bit, I also want to call out a couple of these test points. There are these test points which could be quite helpful for me to kind of debug the situation. For example, this TP7 here, that's a test point for 10 megahertz. This is the 5 megahertz output. This is the 10 megahertz output. I think that TP there is a 5 megahertz test point. So in any case, I'll go through these. So what I will do when I replace this C4 cap, I got some test points with me, so I'm going to install those test points as I debug the board here. All right, so let me quickly switch and then I'll take you to the documentation. So I took a couple of printouts of the Rubidium Frequency Standards product manual. The document itself is not that big. I think it's probably 25-30 pages, and I just pulled out the relevant pages from the document. So this page in particular, this is the page number 3-2. I felt this section was quite helpful, at least for me it was. I'm fairly new to troubleshooting circuits and how to fix them, etc., etc. So this information here is quite useful to me. I also took a printout of the circuit itself, of that buffer board, and I'll quickly walk through what I have learned from it. I got some printouts of the unit itself, just so we can kind of walk through all that. And then finally, the board assembly printout, just so we can kind of relate to where things kind of fall on the board. Before I go in to the details of what I've learned about the circuit, I think it might be valuable to say a quick view of the front panel of the unit. So let me see if I can zoom in a little bit so we can quickly speak to this. Kind of gives us some context coming from the front end. So the unit itself is really fairly simple. There's a power on LED, there's a rubidium lock indicator LED, there's an option selector knob to select what type of TTL, what frequency of TTL you want out on this BNC, 1 megahertz, 5 or 10. And then there is a separate circuit to put out a sine wave of a 5 or a 10 megahertz. So really that's it. I like the fact that they made it simple and very kind of user-friendly, if you will. All right, so what happens when you plug in the unit? Let's quickly jump into the circuit here. I like to start off with this bottom section quick, and I won't spend too much time on this, and I'll quickly jump into this other section. But for us to get ourselves grounded on this section here, let me see if I can move this a little bit. There is this power supply unit made by Lambda, and then the power jumpers, the jumper J1, and J1 on our picture here is this guy here. This jumper receives the 24 volt power supply. The cap on the board, we saw this earlier, but just to refresh our memory, this one here, C4, is the burned cap that needs to be replaced. As you can also tell, let me see if I can zoom in a little bit more. There's a burn on this the power supply trace. I'm not sure how bad that is, and I will have to double check whether it's just a superficial. So I need to check if the trace is still good, or if it needs to be bridged with a copper film of some sorts. In any case, I need to make sure I check on those two, replacing the cap and check the trace, which is what this one has on the circuit. C4, that needs to be replaced. Additionally, throughout the circuit, there are some test points. For example, there's a test point for 24 volt here on the power supply section. There's a 5 volt test point. There's another 20 volt test point. So throughout the board, there are these test points. So for example, right by this cap here, there's a test point 3 for ground. There's a test point here. There is another test point here. So there's several of them, but they don't have an actual test point pin. I have a few in my parts bin, and I'm gonna bring those out, and I'm gonna solder those across these test points and make sure I have a way to measuring those easily. It'll help me to also learn and test the board that much more efficiently. I believe these are through hole. They're just filled with solder. I think I should be able to easily install the test point pins on those without any problem. Anyways, that's just some minor stuff I wanted to kind of quickly cover. As I said, I will not spend too much time on this because I'm waiting on my DigiKey parts, and I will discover more after I replace the C4 cap and test the 24 volt trace. I'll learn more, and then I'll probably do another short video. But for now, on this section here, there is this selector. We saw that in the earlier picture. The selection knob for 1, 5, 10 megahertz switch. That's that. And based on what you select, the internal IC kind of determines what to put out in that front BNC, which is this guy here. So any case, that's that section, and we'll talk about that a little. There's also the main section, which is the Rubidium oscillator and its kind of output, its interface into the buffer board and how it works, etc. So we'll cover that in more detail. On the far right hand section here, there is the two kind of identical filter circuits that convert a TTL signal into a sine wave signal before they get sent out to the front panel BNC ports, these two here. That's those two. All right, so let's quickly dive in. Let me see if I can zoom in here. And I hope this is visible. All right, that should work, hopefully. All right, so let's step back a little. Inside of the enclosure, there is the Rubidium frequency standard unit. The unit is self-contained and self-sustaining, meaning if you supply 24 volts DC to it, it'll put out a 10 megahertz TTL output. Okay, it also tells you whether the signal is locked, whether the Rubidium oscillator has found a lock on its frequency, or whether it's still working on it. So that's the default behavior of the unit out of the box, and everything you see here is really just an add-on feature on top of that, layered on top of that default behavior. So this section here is really talking about once the 24 volt supply is provided to the Rubidium standard unit, it goes into this power on mode, tries to go into securing a Rubidium lock, which is this line here. And that is on the circuit board, that is this white cable. It goes high, that signal goes high, and it's connected at the jumper number 2 on pin 1. It's that white wire. Okay, so let's keep that in mind as we walk through this. So there's a Rubidium lock signal that goes to that comes out of the Rubidium frequency standard unit that tells you whether it has secured a lock or not. Okay, high or low. On top of that, if you look here, it puts out a 10 megahertz TTL signal. Now, while the unit is working on securing a lock, that TTL signal may or may not be at 10 megahertz because it, according to the documentation, that unit requires at least 4 to 6 minutes for it to secure a lock and then put out a consistent standard of 10 megahertz TTL. So there is a line, a coax signal that comes out that is that could be a 10 megahertz TTL, and once it has secured a lock, that will be a 10 megahertz TTL or close to a 10 megahertz TTL. And that coax is this line here that goes to I believe it's jumper number J3. That's this guy here, kind of hidden beneath this white signal line. It's right there. Okay, all right. Now, moving on, let's focus on what happens to that 10 megahertz TTL signal. Now, up here, there is this IC U3 that is responsible for putting out the selected option signal on the BNC port, on the front-facing BNC port. Depending on what you select, that input is fed to this IC, pins 3, 4, 5, and then U3 then determines what to put out on its output pin number 15. Okay. Additionally, U3 also has the pin number 6 for rubidium lock indicator, and that is fed by this white signal line we saw earlier coming out of the rubidium standard unit going to J2, which is this guy, rubidium lock, and that line goes to U3 and attached to pin 6. Okay. Now, according to the documentation, U3 by default out of the box is designed to sending out or not sending out any signal on pin 15 while the rubidium lock is low, meaning while it's still hunting and trying to secure a lock. So while the lock is in progress, while the securing a lock is in progress, U3 will not put out any signal on its output pin, just to prevent from us using an inaccurate signal, if that makes sense. However, you can override that default behavior by jumping pin 1 and 2 together. Okay, so and we'll talk about that here. So let's park that point for a minute and let's quickly jump into this section here. The 10 megahertz TTL coax gets fed into the U3's pin 1 as a clock signal. Okay. And that becomes the source, if you will, for U3 to kind of work on and then put out a signal on 15. Now, we talked about this RB lock pin number 6, and while that is low, by default, U3 would not put out any signal on pin 15. And as I was sharing earlier, you could override that by jumping pin 1 and 2. So from looking at this circuit, it looks like pin 1 and 2 are jumped together. That tells me that override is already baked into the circuit, which tells me that the moment you plug in the power supply to the unit, the rubidium oscillator starts to put out a signal and starts to hunt for a lock. And while it's doing that, output pin 15 will put out some signal in its quote-unquote journey to a 10 megahertz or 1 megahertz or 5 megahertz choice that you made as the output. Okay, so that seems like the already baked in change according to the circuit. All right, so let's follow through that. Output pin 15. That is fed into this chip U4. U4 is the, think of it as the 50 ohm buffer, TTL buffer. It converts a TTL signal, puts a 50 ohm load on it, and then puts out a 50 ohm TTL output on the BNC connector jumper number 7. Okay, which would be, again, just to refresh our memory, which would be this guy here. Okay, so that's jumpers, according to the circuit, that's jumper 7. All right, so that's fairly straightforward. There are some test points here, as we were discussing earlier, and there's also it requires, this U4 requires a 5-volt supply in that is fed by this voltage regulator, and we'll do a test on that once we start doing the cap replacements and other things. So this is another test point, by the way, that is important for this U4 to function properly. Okay, now going on to the next section, the TTL, the 10 megahertz TTL from the oscillator standard takes a secondary path that goes into this U1. U1 is a frequency divider. It divides the 10 megahertz TTL into 5 megahertz TTL. And then the output of that 5 megahertz TTL is fed into this 5 megahertz filter, 5 megahertz pass-through filter. And by doing so, it converts the TTL to a sine wave. And that gets fed out through the front panel on one of the BNCs on the front panel J5, which is this guy here, 5 megahertz. Now, the other path the 10 megahertz TTL takes is it goes through U2, and then basically there's no division required because it's a 10 megahertz TTL already. It gets fed into this 10 megahertz pass-through filter, which then gets converted to a sine wave, and that gets put out on this other BNC on the front panel, which is this guy, and that's it. So fairly straightforward path for that 10 megahertz to a sine wave conversion process there. So really that's it. Those are the big ones. I want to make sure I'm testing through each one of these highlighted stages through the test pins and the test ports and make sure they're all functioning well. And then I'll go into a double click and see why is something not working, if it's not working, and what should I do to kind of fix it, any parts to be replaced, etc., etc. So really that was something I wanted to quickly walk through before I jumped into, taking this buffer board out of the enclosure. And my first job would be, while I wait for the DigiKey parts, I want to go through each one of these test ports and then solder in those test ports so I can be ready to start testing once I replace the caps and fix this burnt trace here. Well, that was it. I'll be right back. Okay, so this afternoon, I got the DigiKey parts for my repairs. Really, for that repair, I only will need this part here, and I'll quickly cover that. But this is the, let me see if I can get a closer view of this. This is the cap that got burnt on that buffer board, the cap C4. I got about 5 of these just in case. These are not cheap. I think they were $7 plus each, and And I thought I'd get a few just to save on the shipping cost, but still, I mean, $7 a pop. I thought it was kind of crazy expensive, but any case, they're here, and that's good. I also got this shipment today. This is the power supply unit in the Rubidium oscillator enclosure. I ordered these from a seller on eBay. Let me put this box aside. I got two of these just in case, and I think these are universal power supplies, universal enough that I might find a use for these in other projects maybe. So these are exactly identical parts, and I'll put a link to this seller in the description, and looks like he's done a pretty good job of packing this together. Let me get this unpacked. Okay, so these two are exactly identical, so I'm going to put this aside and then just focus on this guy. These are not brand new. These are seller refurbished. Actually, that's how they were sold on eBay. So looks very, very well made. I don't see any, at least physically, I don't see any issues. It looks like he included, well, these are not pins that I would use. I would just use the ones that are already in the unit. But let's quickly look at the specs on this one. This is the exact version of the power supply unit in the enclosure. So 24 volt, and there's an LED indicator here, and this would be your the 110 coming into actually hang on, the 110 supply comes into these two pins, and this would be your 24 volt DC that gets fed into that buffer board we saw earlier. Any case, so this is that, and I'm going to do a quick test and see how this is performing. We'll do some measurements and make sure this is doing well before I put this into the enclosure. But outside of that, it seems like it's an exact replica of what's already in the enclosure, and it's refurbished. It looks very new to me, so very good. So let me get this tested, and I'll be right back. Okay, so this here is what provides the 110 volts into the power supply unit. So what I'm going to do is I'm going to remove what's in this box here. I'll take this out, and then I'll connect the new power supply unit with these two wires, the black and the white, and the grounding wire, the green one, and that'll give me an opportunity to test the new PSU. These red and black wires are the 24 volts output from the unit that goes into the buffer board. I won't hook those up yet until I test the voltage from this the new PSU. Okay, the power supply unit is held together by these 4 screws on the bottom panel on the enclosure. So I'm going to take these off and then get the the older PSU out of the box and go from there. Okay, so let me get this turned around, and I'm gonna be careful with this. Let me work on that. It's difficult to kind of maneuver this while I'm recording here. I'll be right back. Okay, so I got this out, and so I'm gonna basically just move these over to this other new power supply unit and do a quick test. Okay, so I got all of these, the basic wiring hooked up to measure the AC power coming in from this, the fused power entry module, or PEM as they call it. Any case, so that's hooked up. I'm going to quickly do a measure. I got to be careful here. So keep an eye on the meter. That should get us roughly 124.56 fluctuates. Okay, that's good. And I believe that's good. And I want to $124.567. Okay, so that's good. So it is, this guy is working, and it is putting out the 120, quote unquote 120 volts. And also, just so you can also see this clearly, the power on LED is lit up, so that's good. The unit is working as expected. We now need to measure what's coming out of the 24 volt ports. Let me get that. I'm gonna change this to DC. All right, and let's measure the 24 volts. That's positive here, and that's negative. Yep, I see. I don't know if you can see the meter, but let's see if I can go around. Meter shows 23.97. Let's see if I can scoot the light a little bit. 23.97. That's good. So we are seeing 24 volts roughly coming out of this, so that's good. There is also a voltage kind of adjust here, but I don't think I'll need to do that. I'm just going to leave it the way it is. And I know now for a fact that this power supply unit is working. I see the power on LED on the unit itself, so that's good. I'm seeing 24 volts come out of this. That's good. So overall, this is looking good. Now we need to move to the next phase, which is to remove, let me get this turned off, that way I'm not touching these wires accidentally. So the next step is for me to work on removing this board and then install the test point pins on all of the test points, replace the cap with my parts from DigiKey, and then let's do another round of testing, and then that should be good. Next step. Okay, so I unplugged this header pin. I have to be very careful with the signal wire and the coax, they're quite delicate. I think the coax is held together by some relief, sort of a clip. So I should be fine, but I still want to be careful. I removed the nuts that are holding the BNC connectors in the front faceplate. So I just need to now remove these screws and then pull the board out of the enclosure carefully. Yeah. Okay, the board is out, but the signal and the coax are not long enough. I want to be extremely careful that I don't damage this. The only other way I can think of doing this is to remove the rubidium oven out of the enclosure. But that seems like a lot of work, and I'm trying to avoid creating busy work for me. If I can somehow manage working through these without having to remove the oven, but I may end up removing the oven. I don't know. It'll be super hard to desolder the burnt cap and resolder a new one there without getting full access to the board. Maybe, I don't know, maybe it won't be that bad. Um, Maybe it's okay. I'm not too worried about the rubidium lock wire. That can be easily soldered back together. I'm very concerned about the coax though. Maybe what I should do, remove these ties that'll free up these two wires. All right, let me figure this out. I'll be back. Okay, I just thought of an idea. This might actually work out, although it's not that straightforward. But the rubidium unit, the oven itself, has this plug-in socket, and then the connector can be easily removed by loosening up these screws. They're not hand tight screws. They're in there quite a bit. So I'm going to have to use something to loosen them up, and then I can decouple the connector from the oven, and then that should free up the board, and I should be able to pull the board out rather from the enclosure fairly easily. So let me work on that. That seems like the best approach here, and I'll be right back. Okay, so that actually worked out really well. So this is sort of like a DB9, DB8, DB15 connector. It's not a standard DB type of a connector you would find on an RS-232 or other kinds of ports. This is a kind of a special adapter connector. Any case, it came out pretty easily. All I had to do was loosen these two screws, and then it came out of the oven. So that saved me a ton of time. Okay, so what I want to do first actually is I want to test the burnt trace. Let me see if I can get a closer view. And I got my continuity setting on my meter, so I'm going to see. So this is the power line trace, and there's a burn here, and I want to make sure that this trace is good. I think it should be fine, but my concern is because this is burnt out, the copper trace is not wide enough anymore because it kind of burned here. So I'm worried about that. So wait, looks like I can actually scratch that away. 1 second, I'll be right back. Okay, so that's good. Let me see how that is doing now. It doesn't look like it's that bad, to be honest. I think it was just as I had originally suspected. It's probably superficial. Well, that's good. Well, let me still, so what I'm going to do is I'm going to do a quick measure from here to maybe going there for continuity. Let's do that. I'm going to put one here. Huh. Where's my circuit diagram? Okay, looks like the trace is fine. I just need to test this cap also. I mean, it is burnt, so I suspect that it's supposed to be here. This is the DigiKey part. It's supposed to be 10 microfarad, right? 10 microfarad. All right, let's see if I can do a quick test. These caps are polarized, so I want to make sure that I'm also looking at the meter here. Yeah, that is burnt. I mean, I'm not seeing any reading on my meter, so I need to replace that. So I'll take care of that. And I'm glad the trace looks okay. That saves a ton of time, to be honest. So I'm going to put this aside for now. I want to be careful. But here are the test pins I got several years ago from a seller on eBay. So I was actually looking for a different kind of test pins, the ones that have a ring, like a circular ring, but I couldn't find them back then. So these are plenty good. So I'm just gonna put these on the board, and I'm gonna replace the cap. Okay, so I'm working through each of the test pins and installing the test ports and installing the test pins. I got 3 done. I'm working on the next one here. I want to be careful with this coax. That's a tricky one. I think I need to put one here on the 5 volt. All right, so, and Alright, so we got that in there. Just need to finish it off with some solder. Alright, let's make sure the pin is intact. Okay, looks good. Let's move on to the next one here. Okay, moving on to the next ones here. TP ground, TP10. Okay, let's go to Okay, I'm gonna remove that damaged cap and put the new one in there. Let me take care of that. I already finished installing the test pins. I want to replace this burnt cap and then we'll go from there. Well, I just removed the burnt cap and it came from here, so it's, as you can tell, it's fairly burnt pretty badly here. So let me get that replaced with the new one and we'll go from there. Okay, here's the new one. I'm gonna get that installed right here and I think we should be all set. And as you can tell, I've also done the test pins. We should be good from that point of view. Let me get this cap installed and then we'll go from there. I think that should be plenty good. Let me get those extra trimmed off here. I think we are all set. There you go. C4 is brand new. We got all the test pins right there, there. We got some here, there, and over here. I think we're all set. I'm just gonna now get this assembled, but before I put this back, I want to be careful and see how best to test this thing, because I need the rubidium connected back to the board, and without it the test wouldn't be possible, to be honest. So let me see how best to do that, and I'll be right back. I probably will put this back together in the enclosure. That's probably the best way to do it, because I don't want to damage any of these coax or the signal wires or any of that, so I just want to be careful. Let me get this set up back into the enclosure, and then we'll go into test mode. Okay, so I got everything put together. There's the new power supply unit, the new cap with the test points on the board, the buffer board. The connector to the rubidium oven is back in there. So it looks like everything is ready to go. I just need to, I plugged in the cord. I just have to turn it on. I hope this works. If this doesn't work, then I'll have to go further and see if I should troubleshoot and see where else the problem can be. All right. With that, let's turn this on, and I'm gonna maybe set this up like so. I'm going to turn off the lights. Well, I'm going to turn off these lights too. Maybe I'll turn on this one. All right. So let's see how this works. The moment of truth is upon us. Ready to go? Check that out. I see the power light. We never had that when I got this unit from eBay seller. So that's good news. We got the power. And we're gonna wait on the rubidium lock status. We'll give it a few minutes. I may have to do some testing. If this rubidium lock doesn't kick in, then of course I'll have to go do some testing with my scope, with my counter, and do some test point measurements also. That'll be fun. The oven should be warming up by now, but I'm not feeling any warm up yet. So there you go. I see the lock. I see the lock. That's awesome. This is working. This would be my very first gear repair ever with this intensity, to be honest. But it's working. So let's do some quick measurements. I'm going to turn on my HP universal counter, and let's do some measurements. I'm really excited about this working. So let's well, outside of these two LEDs, there's nothing else to see here, I suppose. We'll have to move to our counter here. So I'm going to move my light like over there. This guy here. And I'm going to hook up my coax. Let's do the TTL first. I'm going to hook it up. All right. The other end goes to the HP universal counter. Let's put this on port 1, channel 1. It's putting out 20 megahertz, which is it supposed to be 20? No, we'll give it, let's change that to 5. That's 5 megahertz. Okay, so that's looking good. I just flipped it to 5 on my TTL selection. Let's do the 1 megahertz. There you go. That's 1 megahertz. My 10 megahertz is not looking good on my TTL. So the 10 megahertz TTL is broken. Well, we'll see. I'm going to change the source to a sine wave, 10 megahertz. Great. So the sine wave 10 megahertz seems to be working, but my TTL 10 megahertz is not. That's weird because it's a TTL signal from the Rubidium oscillator that goes through the sine wave filter, the 10 megahertz filter. So from the Rubidium, I should have a solid 10 megahertz TTL. However, it's not showing up in the TTL section. So here, I'm going to change this to sine wave 5 megahertz. There's my sine wave 5. I'm going to change this back to TTL 10 megahertz. I'm getting 20. I think we need to give it some time. Why? Well, we already have a lock. It means that we already have the 10 megahertz TTL. So the 10 megahertz TTL from the Rubidium oscillator is already there. So I'm not sure why we are seeing 20 here. I'm going to move to a different counter just to double check. Let me change I'm going to move it to here. To A, channel A. Wait a minute. I see 10 megahertz. So, what? That is interesting. It is showing 10 megahertz, so that's good. So what's wrong with my HP counter here? Not sure. Huh. That's crazy. You know what? I'm going to try this one more time. That's weird. That is weird. My HP should work just fine. Here, I'm going to try this. Enter. So what seems to be the problem here? I'm going to change this to channel B or channel 2. Frequency 2. What? Channel 2 seems to be working fine. Well, it's still settling in, I suppose. Well, that's weird. Well, the good news is this guy's working now. I'm really excited. I'm thankful that I have the opportunity to learn and repair. and that's extremely thankful and grateful for the opportunity. So that's great. So I'm gonna get this packed up, ready to go. But I'm worried about why my oh, you know what? I wonder. Let's try this. I'm gonna try this. I'm gonna change this one gets the 10 megahertz standard from my other Rubidium, but that shouldn't make any difference. That's weird. I'm going to change this to internal. Enter. Okay. Frequency 2, 10 megahertz. Let's try this guy. Frequency 1. Let's see. It's still showing 20 megahertz. I wonder if my calibration is off. Wait a minute. There we go. Interesting. That is interesting. My 50 ohm should be auto, but for some reason it had to be set to 50 ohm rather, 50 ohm for it to measure accurately. That is weird. Let's see. For this, I didn't have to do any. Yeah, but for this, for channel 1, I have to set the 50 ohm selection here. That's crazy. Okay, well, it's working. Great. Well, thanks for traveling this journey with me, and thanks for participating with your comments, etc. And I'm very excited about this working. And oh, by the way, it also helps to have 2 counters in your lab. So this was a classic testimonial just now. Without this, I wouldn't have figured that we are good. All right, so okay, so I've set it up here in my lab. She's working really well. I did some testing offline, and the readings seem to be pretty good. And I tested both the sine wave and the TTL. It's very consistent, it's very stable, and it's quite exciting to have this repaired, set up in the lab, and available for use here. So just a quick snapshot of the test here. I've got this set to 10 megahertz TTL, and the output is going to my 5334B universal counter. It's very stable. It kind of fluctuates between 9.99999 to 10 megahertz. So this is accurate. But then I'm also taking it down to my oscilloscope, and the obviously this is a TTL, and then you can see the frequency and the VRMS showing the readings, and although the manual shows the output level is approximately 1 VRMS with 0.85 to plus or minus 2.5 VRMS when terminated with 50 ohm resistive load. I need to check and see. I have some settings on the scope here, but overall it seems to be okay. Likewise, this is the 53132A. Again, it's quite stable, and it's I'm taking a gated 1 second gated readings. Seems to be working as expected. So overall, this is quite good. So I'm going to change this to 5 megahertz TTL, and there it is on the 5334B, close enough. On my scope, that's close enough, in fact pretty good. And going to the 53132A, that's pretty good. Let's go back to the unit, change this to 1 megahertz TTL. Okay, that's pretty good. Likewise, that's 1 megahertz, pretty good. And on my 53132A, that's quite stable. All right, thanks again. I'm going to leave my other Rubidium standard that puts out at 10 megahertz TTL as my reference across my lab. I'm going to use this for other projects, but given its variable option here, I think that's quite useful to have freely available for other projects and whatnot. So very good. Thanks again for watching. We'll talk soon, and God bless.